And welcome back. The second part of this chapter is factoring by grouping, which means we have 1, 2, 3, 4 terms. Okay, so sometimes they're not going to be in the right order, but most times they are. And so if they are, we're going to first group these two together. That's what we call it factoring by grouping. And then I'm going to group these two together and see what we can take out. Now, I'm going to try and keep these color-coded, but I'm not the greatest, so I'm going to try my best. Here, they both have an x squared in common, so I'm going to factor out that x squared. What we're left with is y squared minus 3. Okay, so just the first two. Saw what they have in common, took it out. Now, since this is negative right here, we have to take out a negative. So if I take out a negative, I guess a 4. Yeah, we can take out a 4, negative 4. If we take out that negative 4, the negative 4 goes out front, and I'm left with y squared, and positive 12 divided by negative 4 is a negative 3. Now, super important step right there, because if these two did not match, then I did something incorrectly. All right? Now, since these two do match, I can actually take these out. So I can take a y squared minus 3 out. And what you're left with is right here, which would be x squared minus 4. Okay, now you might think we're done. Unfortunately, we're not. There's one step left. This is done though. That's y squared minus 3. It's donezo. Love it. Not a difference of two squares. However, this is a difference of two squares. It breaks down to x plus 2 and x minus 2. And that's your first example on factoring by grouping. All right, next up, what do they have? What do the first two terms have in common? So these first two, I could take out a 2, and I can also take out an x squared. When you do that, you're left with x minus 6. Now the next two, you take something out of there. Let's take out a 5. And a positive 5. Since that's positive, we're going to have a positive 5 there. It'd be x minus 6. Look out, those match. Since those match, ladies and gentlemen, we can take those out. Take the x minus 6. And by the way, this gets tricky for somebody saying, well, where do you take it out from? If we took x minus 6 out from each of those, meaning everything in here, since they have that in common, take it out, you're basically getting rid of it. If you get rid of it, guess what you're left with? Well, great question, Mr. Byrne. I'm going to use an ugly color here. You're left with 2x squared plus 5. Okay? And so that's what I mean by take it out, is if they have it in common, you get rid of it. It still stays though. It's right there. Neither one of those can be factored any further, so we are finished with that example. All right, sometimes, ladies and gentlemen, you will need to rearrange terms in order to factor. So right now, if I were to factor it, the first two have nothing in common. Okay? The second two have nothing in common, so we're going to rearrange this. Now, this is up to you. You'll get the same answer either way. But I'm going to go ahead and take, maybe I'll switch these two around. So I'm going to rewrite it, bx squared plus ax squared, and then plus 2b plus 2a. That just makes it look a little nicer. Okay? So now the first two terms do have something in common. They have an x squared. What I'm left with after I take it out is a b plus an a. That looks good. Now the next two, pun intended, have a 2 in common. We take the 2 out, and I'm left with b plus a. Okay, so the b plus a's match, so we take them out. Still have to write them. And I'm left with x squared plus 2. No subtraction here, so no difference to two squares. That is completely factored.